everyone. Welcome you all on board in second day of training program on research methodology for social sciences. We have with us a very renowned scientist in agricultural statistics, Dr. Dhandapani. He is a principal scientist in statistics and computer applications in ICR National Academy of Agricultural Research Management, Hyderabad. He has done master's and PhD in agricultural statistics from IARI. Earlier, he was posted in ICAR, National Center for Integrated Pest Management, New Delhi. His current assignments include Krishi, Research Data Repository for Knowledge and Management. He has been also associated with a large number of research papers and training programs on use of statistical techniques. He is a renowned scientist at national level, like I said. The latest information systems and softwares that are developed by him are AICRP information systems, DHandapani R package, Krishi portal, and repositories. With this, I invite Dr. Dhandapani to deliver lecture on sampling techniques. Please, sir, over to you, sir.
Thank you, Dr. Pundi, for inviting me. And today I have two sessions. One is in the morning and another one at 3 o'clock in the afternoon. So what I planned is that I will be covering the sampling techniques. In the morning session, I will be covering the fundamental things, some of the things which usually missed in social sciences students, particularly when they take these classes, courses on sampling techniques. So incidentally, this was my field of specialization, but I never worked in sampling because after my PhD, I left and started working in different areas. So this is something which I was very much interested during my student days. So I'll be introducing you this technique, sampling techniques. First, let me give you some background why we go for this. I will be covering it a little faster because most of you know about it. And then I will be talking to you some of the things, what are the things you have to consider before you take up any survey. So some of the things, the steps which are there when you in a sample survey, some of the things will be handled by other people like questionnaire design, data entry, data analysis, all these things will be dealt separately. But I will be concentrating more on different types of sampling techniques, why it is, how it is to be done. So, and then I will, at the end of the morning session, I will post you cannot say a very realistic example, but a simple but a example which everybody can understand. So that example, I will post it and think over it till 3 o'clock in the afternoon. And then when you come back, let us again move forward, keeping that problem in our back of our mind, how we can apply whatever different steps which I have discussed in the morning session, how we will do. And also how in the afternoon session, again, I will be touching upon the issue of sample size determination. So the questions related to sample size determination, sample size, all these things, keep it in the afternoon session. So in the morning session, we will be mostly discussing. So let me share my PowerPoint first. Hope my screen is visible. Okay. So if anything is there, please, any issue is there, if it is missing or anything, please inform me so that I can do that. Okay. Good morning to all of you who are joining through YouTube. I heard a large number of participants are there. Let me straight away go into this. See, in any social sciences research, we need to collect data. We need to collect data to answer the research problem you have set. So where these sampling techniques fit into depends on what kind of data you are supposed to collect. There are three different types of data are there. One is what we call it as survey data. The other, which is the for to collect the survey data only, we will be using these sampling techniques. The other two, experimental data, observational data, are again different types of data. So first, let me quickly tell you what you mean by a survey data, because this is where we are going to use these sampling techniques. So a survey data is something where we require some information. We wanted to have this information as a researcher, but we don't know. For example, I want to know how much income is earned by the farmers and from farming activities. Now, this information is known to the farmers. So suppose if I'm interested in a particular geographical area, each farmer or each respondent knows how much they earn from farming activities. But we don't know. So we want to collect these type. And it is not that they may be knowing directly. We can, the thing is that it should be measured. We can measure it. For example, I may be interested to know what is the weight of a children under age 5 or age group 1 to 5. So the weight of the children you cannot say it is known, but we can go and measure it. So basically either they know the value or we can measure it. So if your data is of that type, then we need to go for a survey data. The second type is experimental data. Again, for example, I want to know or I want to release a variety. I want to assess its performance. Nobody know about its performance. What is that performance? So that means this data has to be generated through some kind of means. It is usually we plan an experiment and collect this data. This again in social sciences, if you want, some of the sensory experiments are all these things are usually collected through experimental data. The problem with experimental data is it is very costly, and it has to be done particularly in social sciences, and it has its own limitations for the social sciences problem. Otherwise, in other sciences, this is how many data will be collected. The third aspect is, which is again very, very important, but usually neglected in particularly in social sciences, is observational data. Observational data is something you are observing the natural phenomena. You may intervene or you may not intervene. Some of the work done by Abhijit Banerjee is a kind of survey and experimental data. That is basically an observational data with some kind of intervention. You apply something and you don't apply something, or you intervene or you don't intervene. So this, again, the issues in observational data are something different. We'll not be discussing much about it. So the where we are going to use these sampling techniques, the first thing is we need to know some information, and that information is not available with us, but it is available with our respondent. So we need to collect them. So for that purpose, we'll be using this survey data. So how we collect it? It is usually collected through a sample survey. So why we go for a sample survey, we will come in little later. So a survey, usually there are, when you talk about survey, people distinguish that whether you collect it from all the units, then it is called a census, or if you are going to select few units and go for a survey, conduct a survey, then collect information, then we say that it is a sample survey. Now, if you try to visualize what we are trying to do is that there is something like a bigger population is there. We want to know about a particular information about the entire population, but somehow we don't want to collect information from the entire population, but we want to select a subset, which is a sample, and then we need to go for it. For example, in this pandemic, you might have seen at least 2 or 3 surveys were conducted to assess the antibody present in people in different cities. And the idea is that, okay, we want to know how many people would have been or could have been infected by COVID. We cannot do it for the entire population. So you take a sample and then try to estimate it, whether the COVID antibody is present or not, and then find out what is the proportion in your sample, how many of them are infected, are having the antigen, and then use this information collected from the sample. Somehow we need to project it for the population, entire population, and come to a conclusion or to aid us to understand how this pandemic has affected the city or a state or a country as a whole. So this is what we try to do. But when you are talking about looking at a sample and inferring about the population, one has to be very, very careful. And the reason why you have to be careful, I think you might have heard about the story of 4 blind men trying to understand about an elephant by picking up a individual part. So when you are looking at it, when you are thinking of looking at a particular sample and then trying to understand about the entire population, we should not go in this. So you need to have some kind of idea about the kind of population you are dealing with. So this idea is very well required. Otherwise, what is going to happen is that we'll be looking at, you might have picked up a tail and then you may be thinking that it is a mouse or something like that. So we don't want to make such kind of mistakes. So the entire theory of sampling techniques is try to make sure that you are able to infer about the population with based on a sample on a sound theoretical footing. So that is what we have to be careful. Now, what are the other ways one can go? Because as I told you that there will be always going to be the risk that your sample may not be able to explain, or we may not be able to get a good estimate for the entire population, because that risk will always be there. So what are the alternatives? There are usually, you can go for a census. Census means it is for the complete information. But later on, you can we will see that a census will also have some kind of issues, and that's why the census will be, other than being costly, there are other issues which are associated. That's why census are conducted at a very infrequent frequency, and also very few information will be collected because of other issues. When you go to collect the data, there are other issues are there, which we'll be discussing later on in my lecture. The other alternative is to go for a registration. A registration is that through executive orders or a law or even voluntary basis, one has to submit the data. For example, registration system in our country, too, registration system you may be knowing about, birth and death register, birth register and death register. So this is by law that all births should be registered, and again, same thing, all death should be registered. Same way, for health reason, there are certain communicable diseases. If any doctor comes to that, it should be registered. So this is another way. The third one is through administrative records, because when government does business, there are a lot of data are collected. Like, for example, you pay tax or you pay, say, GST or whatever it is, or as a revenue. So all these things again collect data, and these data from there also we will be able to collect certain some of the issues which we are dealing with can be collected from these administrative records. So again, administrative records has their own issues. It may not be highly reliable sometimes, but it may be difficult or it may not be shared. A registration, again, it has its own issues. Now, why we go for sample survey, I think everybody knows that saves money, time, but the one important aspect of any sample survey is that a very high quality survey can produce a better estimate with lesser errors. Even the country is very small, people still prefer to go for a sample survey because not to save resources, but because you can always get a better estimate than what you can do covering the entire population. So that is why the sample surveys are preferred. And the other thing is, of course, if whatever you are measuring, if you are going to have some kind of restriction, like for example, I want to estimate the timber volume in the forest, you cannot go, you cannot ask for a census because you'll be cutting all the trees. So there is no use of that that information what you collect. So basically, then you have to go for a sample survey. There is no other way. In some cases, you have to go for a sample survey. Now, when it is not possible, sometimes even very quickly you need information. Then in that case, even to plan a survey, to plan and conduct a survey, it is going to take time. It is not that it will be done in 10 days or 15 days. It will take time depending on the area you are going to cover and so many things. For example, census, 2021 census, the preparation have started almost 2 years back, even though the target date is April 1st, 2021. So you can think of that how for a census at a country level, how much time it takes. For example, even a survey can take more than 6 to 8 months from the planning to the first report to come. So the other reason why we don't go for it is that what information you are going to collect is not worth the money you are going to spend. Sometimes we need some basic information, whatever is there, like for example, population count, gender ratio, all these things. We need some kind of a base figure, because this will be used everywhere. So that is why, for some purpose, say for example, census is used for drawing up the counties in US, because every county should have an equal representation in governance. So that is why they redraw the counties are something like our districts, and they just wanted to make sure that every county has equal representation in governance. So that kind of information, if you want, then you have to go for a census rather than a sample survey. Now, you can think of what kind of surveys are there. One, you can think of dividing them into based on the frequency of occurrence, or frequency at what frequency you are doing, and the one is what is called as a cross-sectional surveys, and the other one is longitudinal surveys. And also people classify the survey as interview, one-to-one interview, or it is a mailing survey, or it is a telephonic survey, or an online survey. Telephonic survey, earlier it was very popular. Earlier when landlines were popular, not in our country, I'm saying in US and other places. Now telephonic interviews are slowly it is going out, because earlier telephone numbers, directories used to be there, so people have this. Now with the advent of, with the mobile, nobody has the mobile numbers. So then it becomes difficult for conduct a survey through telephone or a mobile. And online is preferable, but the basic issue is what is called as non-response, and people will not be responding to us, but people use that. A cross-sectional survey is what many of your research problem, because when you are taking up a research, it is usually for one single study you are going to take. So what you are going to do when you go for a survey, it is going to be a cross-sectional survey. A cross-sectional survey is simply you are seeking information or you are collecting information for a particular time period. For example, you may be targeting a say last season or last 1 year. This is the kind of time frame you will keep your study. You will be mentioning that, okay, if I am studying about the income of farmers, I will be collecting income of say last season, say Kharif 2019 or Kharif 2020. So we are going to fix this time period. So any information what you are going to target, it is going to be related to that particular time period. So and typically these are one-time surveys. One-time survey means it has a certain objective and a certain time frame, and you collect information and you produce the result. So you are not going to again and again do the survey. Some of the surveys which are usually conducted, for example, I hope you have heard about this crop cutting experiment, or what is called as GCES, General Crop Estimation Surveys. These are every year they conduct, but it is still every year you have a different sample. So even though it is conducted every year, but every if your survey has a separate sample for every year or every time you do, then it is considered to be a cross-sectional survey. There is no relationship between one survey to another. The other kind of survey, which is very important in many social sciences problems or social sciences issues, is what is called as longitudinal survey. These are very popular in like, for example, basic health or education. These longitudinal surveys are very common, health sector and education sector. The reason is that they would like to see what is happening over time. For example, there are surveys which are conducted which track students from their high school to their say 20 years or 25 years till they pass out, or till they come to the society. So how it is, how they have grown, how they are going, because this information in longitudinal survey provides what is happening at present, and also it can provide information estimation about the change, what is happening over a time. Because when you are studying something over time, what we will be interested will be to estimate the changes. We want to see that. So longitudinal surveys, for example, the other example I can quote is the surveys conducted by, say, Labor Bureau of Statistics, say unemployment rate. So some of the surveys conducted by NSSO, the basic difference between a cross-sectional survey and a longitudinal survey is sometimes some of the sample will be overlapped. Overlapping means that they may use the same sample for at each time period. So the idea is that if you use the same, then it will be, you can estimate the changes very well, because what has happened last year to that same person, how it has changed to these. For example, I'm measuring the performance, so how it changed over time, you can estimate, but you will not be able to get the current level. So what you do, the compromise is, you have a overlapping sample. Overlapping sample means maybe 20% or 30% of the sample will be common between two time periods. So 80 or 70% fresh sample you will take, 20 or 30% overlapping samples you will take. So the idea is that you will be able to estimate the current situation also, and also you will be able to estimate the change also from one season to another season. So these are again very it is becoming very popular because some of the data are now available. These are also called as panel data. So people are trying to use these panel data to get more information, particularly when you are interested to look at the change, then you need to do these kind of surveys. So basically it is nothing to do with how do you select your survey. In the sampling procedures and other things will remain same, but only thing is that you will be doing this survey repeatedly a over a period of time. Now, when we talk about a sample survey or the sampling technique, how to select the sample, I told you about survey data, but the other one more main important consideration is that we assume or we treat the population about which we are studying is finite in number. And the second thing is that every unit in the population is identifiable in the sense that it is not, because there are certain cases where the population will remain finite. For example, you can think of, say, how many fishes are there in the lake. So at any given point of time, the number of fishes in the lake is fixed. So that also is a finite population. But when you talk about sample surveys, another important criteria is that every unit is identifiable. Every unit is identifiable. Every unit is identifiable means that, okay, because this allows you to select a unit through some random process, because you know which unit, so you will be able to select the unit through various schemes. If your population is finite or if your population is infinite, and if you want to select a sample, there is only one way you can do. That is what people call it as a random sample. So that is you select at random. That means equal probability. So there is no other way you can select if your population is infinite. So why we have several ways of selecting units through different sampling scheme is because of these two facts. Our population is finite and every unit is identifiable. So this is what is very important. So let us think of what are the different steps in the sample surveys. As I was telling you in my opening statements, that there are several steps will be there. I'm not going to cover all these things because each one will be one topic. So when you talk about but when you are going to plan a sample survey, you need to know about your objectives of your survey. So the objectives of the survey is going to determine every other thing. So the objectives will be, okay, I want to estimate, say, the farm income of, say, small and marginal farmers, or say I would like to study the adoption of high-yielding varieties in such and such area, or how many of this particular crop farmers growing a particular crop. So you have to set your objectives. So the objectives are not only going to say that what are you going to study, and also it is going to tell you your unit of study, in the sense that what is the geographical area you are going to cover. All these things are going to come. Now, once you have the objective, then you have to define. Let us see in the later on. I will show you what do you mean by a definition of a population. So that means you have to clearly understand that, okay, this unit, whether it belongs to your survey, I mean, you need to consider them or you need not consider them. So this is again something which you have to think about it. And the third, again, what to collect, what kind of variables are there. Again, we will see, I will touch upon this. How do you measure? All these things will come when you are going to select, or when you are going to design your questionnaires or schedules. These things are how to from your objectives of the study to how are you going to collect these variables. This will be dealt in when you are going to learn about questionnaires. So the most important thing is what is your choice of sampling unit and selection method. That's what we are going to talk about more of this. How do you select? That is the physical, or how do you, once I decided that, okay, this is how I'm going to select, then how do you do this actually? So that again, I will touch upon in the afternoon, that how can you do this using a software, or even in Excel also you can do that, but how do you do it? Actual selection of sample. So that is, we will see. How do you conduct the survey? All these things, again, I'm not going to do. And data entry, tabulation, and reports, again. This is all, again, in the analysis part, you will be doing it. So my thing will be something like, I'll be covering only the selection method, and how do you choose the sampling unit, and various selection methods are there. Now, before we move on to the selection method, there are a few things we have to be clear about it when you talk about the sampling technique. So we have a population. A population is collection of units. The population size. The population size as how many units are there in the population. The two things I already told. Many times we know that it is the population size, which is usually denoted by capital N, is known. Sometimes it is required. Sometimes it is not required. You can, without knowing it, we can go ahead and do that. But sometimes we need to estimate it from the sample also. So this is, all these things are possible. But for simplicity, I'm assuming that I know what is the population I am going to deal with it. The next one is, okay, you have a population, but you are going to target, you are going to have a population of interest. So the target, that is called target population. For example, the 70th NSSO survey, situational assessment study, it says that agriculture households forms the target population. So I was telling you that once, okay, this is my target population. Now I need to know, what do you mean by agricultural? And what do you mean by a household? For example, NSSO uses this, that a household is not that somebody is staying in let us say, a hostel or a guest house. Can you call them as a household? You cannot call them as a household. Naturally, the definition of household is typically if they share, and who are the members of the households. Again, because when you are talking about some of the survey, you may be talking about like say consumption or income and expenditure. So per capita income or anything, then you need to know how many people are there, how many earning members are there, and all these things. So what do you mean by a household? It is not just somebody living together will not be considered as a household, but the usual definition is that if they share a kitchen, then all those, they belong to a single household, at least for the consumption point of view. For other, this one decision or any other, they may have individual, because a large giant family will have a different ways of taking decisions. So you have to be clear about what do you mean by household, what do you mean by agricultural households. So all these things have to be dealt, you should understand this, and then you have to proceed, because this one only will help you to identify what is your target population. So the most important thing in once you understand once you have a target population, what we require in to execute a survey is what is called as a sampling design. So this is a technical term which is usually you can see in any of the reports, survey reports, particularly by NSSO or even FAO or any other agencies which conducts large-scale surveys. They will be talking about what is called as a sampling design. A sampling design in survey or sample surveys usually should provide information on two things. One is how the units are selected in your sample. That is the first one. That is what we call it as selection procedure. And the second one is how to estimate it. How to estimate it. Okay, you have a sample. From there, how are you going to calculate? So these two are supposed to consider. That is how the sampling design is supposed to be there. But typically, people sometimes still people will be talking when they say sampling design, they will be still talking about selection procedure. Estimation is usually hidden. But the common understanding now is that when you talk about sampling design, you should have these two things in your hand. Now, when you go for so what kind of sampling or selection procedures are there? There are two ways you can think of sampling. One, we call it as a probability sampling. So we attach some kind of probability to the unit, how to select that unit. That is going to depend on certain probability. We define that probability. That is what we call it as a selection procedure or the sampling method. So that is what we call it as a probability sample. But typically, many times people use what is called as a non-probability sample. Non-probability sample. That is, you go and select as per your wish. This is sometimes they will say fancy names also. They use typically in market survey. Market surveys conducted by many of the private company will have this what is called as a quota sampling or other things. So these are called non-probability sample, but typically we don't consider these as a scientifically designed survey. The reason is that these non-probability sample, they're not, you cannot draw or you cannot draw a valid conclusion about the population. And typically you may be wrong. And no way we can understand what kind of errors are there in your estimates. So that's why we don't consider it. I will be talking only about probability sample hereafter. Sorry. Now, a probability sample, now what do you mean by a probability sampling is that for each unit in your population has some known probability. This probability we have to fix it. So the various ways you can fix this probability. So that is what different selection procedures differ in the way how it is going to select each unit. The reason is why we go for this is it avoids bias. So once you have a unbiased sample, then what is going to happen is that your results can be interpreted at a larger area. Now, the other one is that if you do not have these probabilities, the randomness, if you do not include, then you cannot apply various statistical theory. So if you want to apply the statistical theory, you need a random sample or a probability sample. And the last one is that because it can produce estimates of what is called as a sampling error or error due to sampling. And that is the reason why we go for a probability sampling. All these three things are not possible when you talk about a non-probability sample. But when you say that every unit should have we need to attach some probability, then we need a list of all units in the target population. Now, this is a very, very great limitation, because from where you are going to get, say, for example, I was talking about the situational assessment survey of NSSO of agricultural households. How do you get this list of all agricultural households? There is no list available. There is no list available in any way, in any place, even at a small village level also. It may be very difficult to have list of all households, because without that you will not be able to apply a probability sampling. So, but this can be, so this is what the list is a requirement, and this is what we call it as a frame, or a sampling frame. So, and the another one is that some of the frames may be available, but these frames may not be up to date. They could have been changed. So what we do is that, as you see, that we don't go, if my target is target households, then we are not going to directly, we don't require a list of all households. We'll go in stages. So maybe district, village, and so on. So if you are going to select villages, what you require is a list of all villages. So which is usually available. For example, census provides a list of all villages at one place. Just a minute. So even though our target population may be households, we don't require the sampling frame, because if you apply at different stages, then it will become easier for you, that most of the places you will have the list already available. Only at the last stage you may have to prepare a sampling frame. So that you can do, because that work will become a much less, because you need to have a list only at the last stage, only for the selected villages only you require. So that can be collected, that can be compiled very in quick time. So that's why we can avoid this. Now, the other one is that I was telling you about something like a sampling error. So when you want to understand the sampling error, so we need, first thing is that we want to estimate something about the population parameter. It could be something like income earned. What is the average income? So that is our population parameter of certain agricultural households. So that is our population parameter. Now, how do we estimate? Or I have given this the proportion of household under depth in the country. So this is a population parameter. So when in using the survey or using the sample, we want to estimate this. So how do we going to do is, we need to construct what is called as an estimator, which is a function of sample observation. For the same thing, I can have multiple estimators, in the sense that I can think of, for example, the proportion. This is proportion, so there is no only one way you can do it. For instance, for example, average, I can talk about average income. I can talk about say in a different weighted average or something like that. I can have various ways through which I can estimate the same population parameters. So when you are, so estimators are used for finding out these population parameters. The estimators are usually, we compute based on the sample values. So suppose if I have something in my mind, one population parameter, and I have an estimator, which is a function of sample observation. So if I calculate after observing or after collecting the information from the sample, if I find the value, then it is called an estimate. So this is an estimate. Now, as I told you that there are various estimators possible for the same population parameter. So how do we choose it? So usually they are evaluated based on theoretically we evaluate on their long-term performance. Long-term means a repeated if you think of applying this estimator repeatedly for several samples, then how do they prefer? How do they prefer? So that's how we do it. So so this, the one which is having what we call it as sampling error, and that the one which is having the sampling error are what is called as a precision of an estimator, which is basically the variance, or you can think of something which you might have studied earlier also, what is called as a standard error. So we need to have an estimator which is having less standard error. Here in sample survey, the term which is usually used is called sampling error, because in a survey there are several errors are there. So they are clubbed together into two. One is sampling error, another one is called non-sampling error. Of course, we need to reduce this. Then what is sampling error or what is non-sampling error? See, when you are going to use a sample to estimate the population, so you are no way you can say that the sample values is going to lead to the exact value of the population. There is always going to be a difference between what you compute in the sample and what you compute for the entire population. If you observe for all the units in the population, sampling error will be zero, because you have observed all the units, so there will be no issue. So then there will be no sampling, because we are going for a sample. So there is going to be a some error which is going to occur, the difference between what you have observed in the sample and what is there for the population. So that error, we call it as a sampling error. So this is inevitable in any sample survey. But there are going to be non-sampling error, so errors which are coming other than the fact that we are observing a part of the population. We term them as non-sampling error. How they come, let us see. What is this sampling error first, and then we'll go. So why we need this sampling error is it measures this uncertainty in your estimators. So it shows you that, okay, we want to estimate this, we have used the sample, we have got one parameter, but we know that it is not the exact value. So how much, what is the uncertainty we can attach? So this sampling error can be estimated from, because we know what is the probability of selecting a particular unit, so we can compute it, and we can find out theoretically that what is the sampling error. So we want an estimator which is having a low sampling error, so that we get a better estimate. So while selecting an estimation procedure, we will evaluate the sampling error for different competing estimators, and we choose the one which is having a less sampling error. Of course, this is a theoretical concept, but you can estimate it even from the sample. You can estimate what is the sampling error. So how it is going to depend upon? It is going to depend upon three things. One is what is the variability in the measuring parameter, because if you are the parameter which you are going to measure, if it varies, the sampling error also will vary, because you are using something like variance of some measurement. So because variance measures how far individual observations differ from your mean. So if your mean, if your individual values vary, your variance also will vary. So same way, whatever parameter you are measuring, if individual values vary, your sampling error also will vary. But that is inevitable. But the second thing is that the sampling error is also dependent on what kind of selection procedure you will use, because certain selection procedure will using that you will be able to reduce this sampling error. So that's why it is important to understand various selection procedure and choose the one which will lead to you a less sampling error. The third one is most of the time, in almost except one, the sample size is sampling error is also going to depend on the sample size. That typically, if you have more samples, the sampling error will decrease. So there is an inverse relationship between sampling error and the sample size. So if you increase the sample size, sampling error will come, except one, I will tell you which one, which selection method. For all other selection procedure, the inverse relationship holds good. Now, what do you mean by a non-sampling error? This non-sampling error, we can broadly classify into two things. One is errors due to non-observation. Errors due to non-observation. Errors due to non-observation means that we have, say for example, we are not covered a part of the target population. We are supposed to cover the entire country, but maybe we left out certain parts of the country because of various reasons. So that we call it as that due to that you have a non-sampling error. The second part of how the non-observation or errors due to non-observation can come is that, okay, you have selected a sample, but some of them are selected units, you do not get a measurement. Say this is what we call it as a non-response. A non-response may be you have selected a household, that household nobody is there, or nobody is willing to answer your questions, all the questions, not even one. So that is the complete non-response. Or you are not able to, for example, if you are mailing your questionnaire to somebody, and if they are not responding to you. So this will lead to a non-response. A non-response bias is very, very serious because due to if there is a bias in responses, you are going to get this bias is going to seriously affect your estimate. The other kind of non-response is that, say for example, for a certain question, some of the people have not answered. They answered say 80% of your questions, but not say 20% of your questions. So you have, this is in sampling terminology, it is called item non-response. The first one is called complete non-response, and the second one is called item non-response. Item non-response means that for a particular variable, you do not have a data. For example, you are asked say, what is your age? So sometimes they're not told, or you are not entered, or they are not answered. So that is called an item non-response. For all other things, you have values. So why again, this non-response is a very great, it can cause serious damage to your estimates. The very famous is this one, non-response bias due to non-response. If you want, you can check in the internet about the survey conducted by a US newspaper on presidential election. I don't know the year. Truman was the name of the president. He was selected, but a publishing house declared the opponent as the winner. But when the actual research came, the exactly opposite happened. The newspaper believed that they have sent a questionnaire to so many people, and they have a huge number of responses, and then they thought that their whatever sample they have is very huge, and you will be able to predict the exact answer. But what has happened, they say, is that the people who are supporting Truman were not covered, or they are never responded to that particular survey. So you have a biased survey, and based on the biased survey, what you get is an estimate which is entirely opposite of what you get it. So this is what will happen if there is a huge non-response, and that is why many of the time, if you look at the survey reports or the papers based on sample survey, many of the international journals will ask you what is your non-response rate, because you are selected and say 30% of your samples are not, or 20% are not responding, then it may be your sample may be biased because of this. why certain people are not responding to your questions. Are they belonging to certain, they share certain characteristics, they are not responding. Due to that, your entire result could be wrong. So you have to be careful. So of course, people try to follow up, do all these things to reduce this non-response to less than 5% or 8%, like that. And but of course, you can't go on behind these people to make it to get the response. Up to 2 times, 3 times they try. After 3 tries, if it is not responded, then you'll have to close it, because at one point of time you'll have to close your survey. So you have to be careful about this non-response. The other one is errors in observations. So typically what is called as frame over coverage, in the sense that you have included some non-target population units in your frame, and then due to that you are going to have certain error that you can avoid. Try to avoid these while constructing your frame. But the more serious error will be measurement error. A measurement error, I will tell you how it can come, these measurement errors. So it could be data entry error, or so many ways these measurement errors can come. So to put all this in perfect, in a good perspective, this I find it is really you can understand how these, when you are talking about a survey design, then what ways your errors could be there. So you have a construct on the measurement side, if you see, and this is on the survey side. So both these two things are going to provide you the survey estimate. So in every step, when you go from one to another, there is going to be an error. And if you understand those errors, you will understand how to get a good survey estimates. The first one is you have defined, say income. That is your construct. So how are you going to measure income? So that is the constructive measurement. So many of the things in social sciences, as you will be knowing now, that you have certain thing in because many of the things cannot be measured directly. So you need to have in an indirect way, you will be measuring it, constructing a scale or something like that to understand the phenomena you are studying. So there will be always this, from construct to measurement, if you go, there is always going to be a construct error. The construct error will be there. So now you have defined a measurement, you are getting a response. Again, there is going to be some kind of mismatch or some kind of error will be there. So this could be because you are, say, for example, I'm using a scale. So that say weighing scale may be having some kind of measurement. These are typically called measurement error. So that could be there. And again, another one is that I ask certain question, and the person who is responding might have understood in a different way. So their response is going to be some kind of error will be there. So this is typically a measurement error or a response error. So recall errors, all these things will come here. So from the response to when you go to edited response, in the sense that you are converting this into a data file, or you are constructing an electronic file. So there could be some data entry error maybe there, maybe in whether you are, when you are editing it, or when you are putting it, suppose you are collecting it, when the enumerator writes it wrongly, or the data entry operator writes it wrongly or enters it wrongly, so you are going to have an error. So this is from the response side. But if you look at the target population, the first one I was telling you that you have certain population in mind, and you have constructed a frame. So you may encounter two errors. You have included certain units which are not there in your target population. certain units which are supposed to be there in your target population, you're not including them. Then from the sampling frame, when you come to sample, so this is what the sampling error is going to be there, right? So from sample, you are going to have a respondent. So here, what you are going to get is what is called as a non-response, because this is where you have selected 100 people, 70 people have responded, so 30 is non-response. So that here, what you get is a non-response error. And from respondent, what we do is some kind of post-survey adjustments are made, particularly to reduce this non-response error. So that is, again, it is going to add up some more error. So what you get is in every step, you are going to have some kind of, at one stage, you will have a sampling error. But if you see here, many places, what you get is non-sampling error. So the only error which you are going to have is from you go from your sampling frame to sample. That is where the sampling error will come. And in all other things, the non-sampling errors are going to be there. Now, if you think of that, if you are going to conduct a census, then you can see that in census, only the sampling error is not going to be there. Every other things are going to be available. So that means, that's why always people will say, if you are able to do a survey in a proper way, the overall errors can be reduced. Because when you are handling less number of units, you can reduce these non-sampling errors. But when you are doing a large number of, when you have to collect large number of units in a census, you are going to have a big issue. And that's why most of the census, if you see that, they will make sure that they will be collecting very simple information, so that it becomes easier for them to reduce these all non-sampling errors. Of course, time is also another factor. Now, after having understood all these basic things, let us move on to how we can select a sample from various things. Now, there are various ways you can select. These are some of the things which I will be discussing it with a little bit more. Now, the one which is, and one thing is that every time you ask, or every time you see in any social sciences research, is that when the question of they will say that, okay, mine is exploratory research or confirmatory research or whatever it is, then they will come back and then they will say that the first thing they will say is that I have done my sampling method is stratified multi-stage random sampling, like that they will be saying. But many times I just ask them, okay, what is your what do you mean by what is your strata? Then people get confused, and then they say that it is always stratified multi-stage random sampling. But try to understand, what do you mean by stratification, what do you mean by multi-stage, and what do you mean by random? Because in statistics, all these four words have certain meaning. It is not that you cannot put everything in whatever may be your sampling scheme or sampling method. You cannot put them into these four phrases. But every time, I think most of you would have realized that whatever study you have come across, you might have seen this stratified multi-stage random sampling. That's what they use. Now, when you say in statistics, when you say random sampling, whenever somebody says it is random sampling, it means only one thing. This is what we call it as simple random sampling. Strictly speaking, simple random sampling with replacement. Later on, I will tell you what you mean by with replacement. But here, simple random sampling, when you say that, is people call it as a random sampling. That is the simple name they use. So when you say a random sampling, every unit in the population has same probability of being chosen. So suppose there are 100 households in a village. So if I'm going to select certain number of, say 10 or whatever it may be my sample size, so every household has equal chance of being selected. So this is the very easiest thing you can talk about. And this is what, whenever you say a random sampling, the actual meaning should be this. It is every unit has a same chance, same probability of being chosen. So don't use random sampling for something else. So random sampling means that it has equal probability. Now, this is the very simplest one because the easiest one you can think of and easiest way you can handle the estimation procedure, calculating the sampling error. All these things are very, very simple, very, very simple. So that's why this will be the one which will be introduced. But if you think of applying this in any real life, it says that you need to have equal probability. So if I'm thinking of, say, for example, the study area is entire districts, and I'm talking about, say, farmers are my sampling unit, the unit I have to select. So if I'm going to apply this simple random sampling, what I require is list of all farmers or list of all households in the district. So from where I'm going to get this? I'm not going to get this in any way. So I cannot spend my time to generate this sampling frame because that itself will create, that itself is going to be costly as well as time consuming because I need to have the complete frame. No way you are having it. In no other way you are having it. So that is the reason you cannot use this, even though it is very simple. You cannot use it for a large geographical area, but it does not mean that it is not being used. It will be used at a different way, but this is the one which you can do that. How do you select it? It is very simple. You can use, say, for example, in Excel, you can go and suppose I need to select 100 units I'm having in the population. I have to select 10. So the simplest way is you go and use a function called rand between. Then if your population size is 100, from 1 to 100, you put 1 comma 100, then it will generate a random number between 1 to 100. The only thing is that if you want to select 10, you cannot select only 10, you need to select more than 10, because if the one unit is selected, say fourth unit is selected first, then again it may come after few rows. So then you have to, you have to ignore them, and then you need to select how many district, whatever is your sample size, that many district units you have to select it. So we'll see in the afternoon how to do it. I'll try to show you how to do it in Excel itself, because that is very simple. Now, the another simplest sampling procedure, which is again, it is very easy. But say, for example, again, I'm just taking a simple example to make you understand how it is useful. Say there are 100 households are there. I need to select, say, 20 households. Now, what you do is first you divide the number of households, a total number, by the sample size you require. So so that means 100 by 20. So that is 5. So what you have to do is, instead of selecting 20 random numbers in simple random sampling, here you'll be selecting only one random number between 1 to 5. So whatever may be the number selected, say 4 was selected. 4 was selected. So what you have to do is, the first number you have selected randomly, and the subsequent households will be selected adding 5 to the initial number you got. So from 4, then that means you select 4th household, then you leave you go to the every fifth households, you go 4 plus 5, 9, 9 plus 5, and so on. And then you will be getting 20 households. Of course, there will be complication if the total number cannot be exactly divided by the sample size. That will be one issue will be there. So all kinds of things, then you go for some modifications are there, like circular systematic, like that. So if it is, you can make it in such a way that if it can go again, it will start from one. So that way you can handle some of these issues. But even though it is very simple to use, this will indicate, you can run into a serious trouble if some kind of trend is there. Think about it, suppose I am selecting, so it falls under a particular street, or you are selecting, and then it comes to a particular way. Maybe it is in the very first corner houses. Maybe all corner houses in the street, maybe a very rich households. So in that case, what is going to happen is that there is a serious bias in your sample will be there. So, but the biggest advantage of systematic sampling is that if you look at it, you don't require a sampling frame. You don't require the list of all households, right? Only thing what you require is what is the total number of households. That is what is required, right? So that is the biggest advantage, and also it is very simple to use it. This is very popular in two real surveys. One is that in the auditing, people use this systematic sampling, because if you go for a simple random sampling, for example, an auditor wants to audit, say 1,000 or 2,000 bills are there. All of them are having numbers, so you have no issue in creating a sampling frame. But the problem is that if he's going to select a simple random sampling, then it may say that, okay, you'll have to take 21st, then you'll have to take 47th, and so on. So then it takes time for them to pick up the bills they want to check. On the other hand, systematic sampling, they can go select 1/4 bill, then you take every fifth one, you go on select, removing it, and it becomes easier. So that is the one. The other one is that mostly in forest survey, people use systematic sampling because there is no way you can mark the tree. There is no identification is available, but you can estimate the total number of trees, and then you can go on without marking. You can go in any direction and do that. Typically, the systematic sampling in many large surveys will be used at the last stage. But one point I was making in the beginning is that it is the sample size and the standard error. In systematic sampling, there is no relationship between sample size and standard error, in the sense that if you increase the sample size, there is no guarantee that your sampling error will come down in the case of systematic sampling. But in all other sampling procedures, the relationship holds good. So, but the systematic sampling, again, has certain advantages, but also it is disadvantage. But don't go for systematic sampling as the primary sampling tool, unless the type I was explaining to you. Other than that, people do not use systematic sampling because in fact, if you apply only systematic sampling, you cannot estimate the standard error. Okay. Now another one, people again get confused when you say a cluster sampling. Again, a cluster sampling means that what we try to do is that if you think of a simple random sampling, the selected, for example, I use simple random sampling to select villages. Say I selected 20 villages. Now what is going to happen is that these 20 villages will be spread across the entire district. So when it is spread across 20 districts, you will have to go to each village and then collect the information. So that means you are going to spend both time as well as resources, money is required to go from one village to another, and it is going to increase your the cost of the survey like anything. So the one alternative to this is that you can think of, okay, instead of doing a simple random sampling, why can't we of villages, why can't we group the villages in the sense that, say, maybe adjoining 2 or 3 villages forms one cluster, one cluster. So this, once you say that these 3 or 4 are going to be one cluster, so you select clusters, not individual villages. Instead of that, you will be selecting the clusters. Now, once you have selected the cluster, all units in that cluster is automatically selected. So the advantage of that is that you will be covering a more number of sampling units in lesser time, because 2 villages you have selected, they are all adjoining villages. So that means your traveling time, traveling cost, all these things will get reduced. But what will be the disadvantage? Advantage, you can easily understand that it becomes simple, and it will reduce your travel time, travel cost in a very significant way. But what is the what are the disadvantages? The biggest disadvantage is that typically what happens is that if you are grouping them together, they look more or less same. The trend in adjoining villages will be similar. So when you have adjoining villages similar, what is going to happen is that there will be, what you are going to get, you will not be capturing the complete variability. So you can increase your sample size, but your precision will not increase. Precision will not increase. The precision will increase only when you are able to capture the variability. So that is the reason cluster sampling will be inefficient as compared to even simple random sampling. But cost-wise, the cluster sampling has a huge advantage. Even in urban areas, you can think of that, okay, for example, you can select a complete apartment. Say it has 4 houses or 3 houses or 10 houses so or even a floor in a particular apartment. So all households in that particular apartment, you select it. So you are able to increase your sample size, but the precision is not increased as much because the individual apartment, the adjoining units or the units within the cluster will not show most of the time variability. So which will not increase your precision. So your precision will be less. Now, the most see in any sampling method, when we are trying to do the most important objective is one is that we need an improved precision at a lower sample size. So we tried all kinds of means, not only in selection, but also in estimation, that our sampling scheme and the estimator should provide an estimate at a lesser sample size, but at an increased precision or improved precision. So how do we achieve? One way to achieve is to go for what is called as a stratification. Stratification is that because if you consider population as a whole, there will be huge variation will be there. So when there is a huge variation, to capture this variability, you need large sample. Without that, your variance will not reduce. So how do we achieve more precision with lesser sample is that you can try to divide the population into non-overlapping groups. That is, you divide the population so that in different groups. So within the group, the units will be more or less same, or less variability will be there. The variability is less. And between the groups, the variability may be different. Maybe variability may be different. So the The purpose is, of course, to increase your precision at a lower sample size, because once you know that this within this stratum, the units are more or less homogeneous, then you require a lesser sample within that group. So the overall the sample size will decrease, but it will be you will be able to increase the precision. The another advantage of stratification is that it is possible. For example, there are certain, let us say, um, certain areas is inaccessible terrains. So if you go for a stratification, then you can think of different way how you will collect the data. So because for all other places, you can apply a different way, because this stratification is about dividing the population in, we are not talking about how are we going to select. So within each stratum, we can apply any selection procedure. For example, I can apply a simple random sampling in certain number of strata, cluster sampling in another, because in a hill area, I don't want to select the villages which are far away. So I can have a cluster of villages so that I can do that. So operationally also, it will be very, very convenient, but at the same time, you are able to increase your precision. Now, what could form as a strata? For example, in our country, if you look at there are large scale surveys which are conducted by statistical agencies, people use, the agencies use state, if it is a countrywide survey. So what they do is they divide the state into certain regions. You can consider state also as a stratum, but state region, because within the state, again, there could be huge differences will be there. So you can consider a state region, say, I think in, like, for example, earlier Andhra Pradesh, we had 3 different regions. One is called the Telangana, then Rayalaseema, and Coastal Andhra. So these are 3 different regions. So many state has these. For example, in UP, you have Bundelkhand and so on. So you can divide these into Western UP, Bundelkhand, Eastern UP, something like that. And then the idea is that within this region, the districts will be somewhat similar as compared to if you consider entire state as a single unit. The another one is that you can think of district as a strata. And if you are considering state as your geographical area, state is your target area, then district could form as a strata. The first one I'm talking about a country level survey. But if you are having district, you can go as a district as a strata. Yeah. Then you can also think of that, okay, some districts are very large. So you can divide the larger districts into, say, more than 1 or 2. So for example, NSSO uses, if a district has more than 25 lakhs, then it gets divided. So it is no longer that you have to go for as per the administrative boundaries. So you can think of, okay, you can club these 2, or you know that these areas are a little bit more similar, so you can form them. And typically, sometimes at some of the surveys, you can see that they go for block level or a sub-tehsil or sub-tehsil level. That forms the strata. The other one is that you can think of that, for example, urban areas may be further divided based on their population size. So depending on your the target study area, you have to think about that. How are you going to divide this? So the division is usually dependent on how similar or how vary are they. And there are various ways. I will come a little bit more. Just a minute. Let me take a break for 1 or 2 minutes. one phone call is coming.
Okay, sir.
Okay. Hello. Okay, I mean, okay, okay. I'll call you back. Okay, sorry. So this is different ways you can have you can form a strata. So a stratification, whenever you are saying that I use stratified multi-stage, then stratification you have to tell that what forms your strata. So that is the one which you have to tell. Now, once you start using stratification, the three different selection procedure which I told you, whether it is simple random sampling, or systematic sampling, or cluster sampling, in all these things, the probability of selecting a particular unit remains same, in the sense that every unit in your population has equal probability. But when you start using stratification, what happens is that you can think of that why we should give the equal probability for to all the units. You can have unequal probability. So when you say unequal probability, that each unit has different probability of selection. So you may be thinking that why we should go for unequal probability, because I need every unit in my population should have equal probability. Now, the reason why stratification you can also achieve equal probability. It is not that it is not possible. You can go for equal probability under stratification also, but in that case, the sample size for each stratum is going to be proportional to the size. For example, I have certain number of units I need to select 100. So depending on say I divided the entire district into say 5, and one first stratum, it has certain number of villages. Second stratum, it has certain number of villages, something like that. Then suppose I have to select certain number of villages, that should be allocated proportionally to the number of villages under each stratum. If you do it, then it becomes equal probability. But there is no need of going for that. I'll give you the logic why we need a unequal probability sampling, or even a sample size which is not directly proportional to the stratum sizes. The reason is that, for example, I'm trying to conduct a survey for a particular crop in let us say in a particular state. Now, every state or every village may not be growing the crop in similar way. In some villages, the crop may be marginal crop. In some other villages, the crop may be the most important crop. Now, you don't want to select those villages, or you don't want to treat those villages where the crop of our interest is not the main crop. Why we should give equal probability to a village where it is grown in say 5 acres, and why we should treat another and that this village is treated equally with another village where 90% of the crop area is under that particular crop. So what we require, because we want to, our sample should be, many times people say it should be a representative sample. So what do you mean by a representative? So if that particular village is growing that particular crop in a large area, then those should have higher probability of being selected as compared to the others. So, and that leads to what we call it as unequal probability of sampling scheme. So besides simple random sampling or systematic sampling or the cluster sampling, we can also think of going for unequal probability sampling. But when you talk about unequal probability, we want to assign unequal probability. So based on what? So we need certain variables, which is usually called as auxiliary variables. For example, area under the crop can be treated as, can be used to allocate these unequal probability. So the area under the crop, the probability will be proportional to the area under the crop or any other way. So in that way, we can achieve unequal probability. The reasoning is that if it is, again, it is related to the precision of your estimator, because if you are allocating the probability based on certain variables, which is closely related to the variable of your interest, then your precision will automatically increase. But the problem in unequal probability sampling is that we have to apply only at the initial stage, because these information will not be available. How you allocate, for example, area under the crop at a village level, you may not be having it, but you may be having it at a block level or a district level. So you can use it at a larger unit rather than at a very small unit. So use this unequal probability sampling scheme, particularly to select at the initial stage. So because it can include, it can increase your precision. Now, the one issue comes, I was telling you that with and without replacement. Basically, a without replacement means once a unit is selected, then it is not considered for selection again. On the other hand, when you say with replacement, the same unit may be selected more than once. In any typical survey, we use without replacement because we don't want to say, collect the information from the unit from where we have already collected it. But and also from statistical point of view, without replacement is better or efficient as compared to with replacement. The reason why I brought this is that sometimes in standard error estimation, or when you want to estimate the standard error, it will be very difficult to compute the standard error when you have without replacement. I will have another in just one more 5 minutes, I will be winding up.
Sure, sir.
Okay. So the last type of selection method is multi-stage sampling. In multi-stage sampling, it is what we use in a large-scale surveys. So the reason is that if you are thinking of a large geographical area, you need to divide this large geographical area into various stages. For example, I can think of villages is my first stage, second stage it could be fields, and third stage could be plants within the selected fields. So the understanding or the idea is that so if I want to apply any of these probability sampling scheme, I need frame only for villages. So list of villages can be collected quickly. So you collect it. So once you have selected certain villages, then you need the list of all fields within that selected village. So again, it may not be available, but now you have only few villages. You go to the village before anyhow you have to go to the village to collect the data. So go to the village and collect the list of fields which will be available with the village administration. So you do it. So that way the complete frame list of all units are not required. So you need list of the frame is required for at each stage. And the another advantage is at each stage you can have a different way you can do. So I can, for example, in this case, if I'm going for a statewide survey, I can use district as my data. And in each district, villages will form the first stage unit. So what I need is the list of all villages that I can get it. So I can go for unequal probability based on some criteria, maybe the population of the village or something like that, which is again available. So the unequal probability based on the population size. The second one will be, I need a list of all fields within the selected village. So this frame, I have to collect it for this only for the selected village. So I can apply maybe simple random sampling or whatever it is, and go for the third stage. I can select it with any way. So this is how you do. Now, this is how the pictorial representation. So out of all these one, we may be selecting the first stage. Then within the first stage, you will be selecting the circles represents the stage, first stage unit, the triangles represent the second stage unit. So you select few first stage units, you select within the first stage unit, you select certain triangles. So that is how what we do in a multi-stage. So if you have divided your say state into district as a stratum, so in each stratum or in each district, we will be selecting it. So when you say stratified multi-stage, you'll have to say, okay, districts forms my stratum. Then villages forms my first stage. Second stage is the households within that selected village is my second stage. Maybe the third stage could be the member of the household, because I'm asking only, I just wanted to ask individual opinion. So I may select, or I may select only one. In that case, only two stages are there. So you have to be clear about different stages. So what we are trying to do in all these things, we need to estimate certain quantities. So we need to estimate it based on a sample. Now, I try to explain to you how these samples can be selected. So the last part is we have to discuss about is that how do you find these estimators? Once you have collected the data, then how do we estimate the population parameters or the quantities which we wanted to start at the first page? So now let me put up an example. Of course, I think this now at present during pandemic, it may not be an appropriate example because nobody is traveling now. But suppose an organization wanted to estimate the traveling time to work by their employees through the survey. So basically, this kind of surveys are conducted to understand, like for example, in ICR system, people talk about that 5-day week or 6 days a week. So basically, one of the idea they put forth is that you can reduce the traveling time spent by the employees. And many studies have shown that if they travel less, they will have more energy and they will be contributing more to the organization. So this is one, many of the private companies, they try to understand this, what is the average time spent for that, because it is considered to be unproductive, particularly if you are driving, you are on your own, this is an unproductive time. So even government is thinking of that, how do you reduce the unproductive time? So this is, of course, it is, don't think that there is something which is there. It is just a fictitious example. So in the afternoon, think about it. So you learned about selection procedure. We talked about the frame, all these things we have talked about. So how do you apply these if this is the objective of your survey? I hope this is a simple one. Think about it. Then in the afternoon, we'll take it up the remaining thing in a relationship with this problem, so that you have how you can apply whatever I talked about. So let me stop here in the morning session. So so I'm stopping the sharing. Now, I think it is a question and answer session.
Yes, sir.
Okay.
Sir,
How do we,
shall I ask, or you want to have these question and answer in the latter half?
no,
There are many questions.
We can
Okay.
have maybe up to 12. I can spare another 10, 15 minutes. We can go ahead and we can have the questions. So,
Okay.
So if you can read out, you can You can do, otherwise one thing you can do is you send me in the chat the YouTube link. I can see it from there and I can answer it.
So I can ask also here.
Yeah, sure. Sure.
So I'll start asking.
Okay.
So how to validate that the sample which is taken is a true representative of the population?
Okay. See, the one thing people use is that representativeness in certain ways. The one way is people say that, okay, whether all social groups are covered. Suppose if it is, if I'm seeking opinion from somebody, then I have to make sure that the different social groups are covered. For example, in agricultural side, you can think of that, okay, whether we know that there are certain number of small farmers are there, certain number of medium farmers are there, certain number of large farmers are there, or marginal farmers are there. Now, this proportion we know. Now, one way people insist is that our sample should be also, the sample also should cover these 4 or 5 different kinds of farmers in the same proportion. So 20, say 10% of our large farmers. So our sample also should have roughly about 10% should be of large farmers. So this is one thing people try to see that, and they try to put it, and they also try to see that this ratio is maintained. If it is deviating too much, then the results are taken, because in a truly random sample, we may not be able to achieve it unless you try some other way to make sure that this ratio is maintained.
So for knowing that the proportion of large farmers and small farmers or medium farmers are this much, we need to have a sampling frame before this. And so, getting a sampling frame itself is very difficult.
So the one way is at the last stage, when you are going to select the farmers, you try to keep this, because till that time we will not have any list to select certain number of large farmers, certain number of small farmers, because we don't have the list.
Right.
So you can go to the last stage. So you go to a village, you have selected certain number of villages. In that village, when you need the list of all farmers. So then you can collect this information. When you are collecting the list of all farmers, you can also collect this list. Okay, so in this list, how many are small farmers? Along with their names, identification, you also collect this information, whether you can classify them as a small farmers or a marginal farmers. It may not be 100% reliable, but you can have certain idea that, okay, based on talking with others, and then you can classify. Then suppose you have to select 10 farmers or 5 farmers in a village, then you can select it in that proportion. So that will overall, it will lead to the similar proportion.
Okay, so that will be based on our assumption, huh?
Not assumption.
See, like proportion that you are saying. So that
at the country level we know, or at the state level we know. So that proportion we know. Now, only thing is that when we are going for the last stage, when you are going, at that time we have to select certain number of farmers.
Right.
So you select that according to this proportion.
Okay, sir. Fine.
Right. That will more or less, it may not exactly, it may not match, but it will be somewhat, it will be closer to that.
Okay. Fine, sir. Okay.
Right.
So the next question is, what is haphazard selection in non-probability sampling?
See, haphazard selection means I can just, typically they use it in, not in social sciences, but in some other, say, even in this one, in quality control, or for example, I need to select the quality of a seed or any produce. I can take one from here, one from there, something like that. It is this one, hoping that you are selecting it randomly.
Okay.
So if instead of selecting it here and then I will select somewhere here like that, select it and thinking that it is a random sample. So that is what is called as haphazard selection.
Okay. Okay. Fine, sir. Um, in social science, we have a practice of using purposive sampling mostly, which is based on our judgment that okay, this person or this area will give us information more convenient for us to collect the data. Is it the right way to do sampling?
No. See, if you do not go for a random sampling, what happens is whatever you have collected cannot be interpreted to a larger area or to the entire population. See, your district should be purposive. A district which you are studying could be a purposive.
Okay.
So that because based on your judgment, you have seen that, okay, within the state, I am selecting top 10 producing districts. That is my study area. Even though I am interested to study about that particular crop for the entire state, but I don't want to, I know that time is not permitting, the cost is not allowing me to do, but I will select only the top district, which is producing that district. So I am selecting that district as a purposively,
Okay.
but with some justification.
Hmm.
Hoping that the largest produced district is give some idea about the entire state, but it may or may not be whole good, but still that is considered to be giving you certain idea about what is going on in that.
Okay.
Right. But
Right.
if you say that I have selected one village in a particular district and I have selected few farmers purposefully, or I have selected few villages purposefully where which is very near to the main road or highway, and I contacted few people whom I saw when I visited, and based on that I collected certain information, and I'm having this information that you can say it is throwing you some light, but it could be completely misleading and you cannot project it for the entire state. That is what is happening. Okay, it is something like a news reporter going around the city and then asking few random people and then saying that that is the opinion of all the people.
Hmm.
You know how wrong it could be. So the thing is that many of the social sciences, what happens is particularly student or even some of the research project, because of the cost constraint, because of the time constraint, people think that, okay, if I do like this, it is also a sampling method. I use purposive sampling. That is also a sampling method. No, you can do all these things, but you cannot project this result for the entire population. You cannot say this is the opinion of all the people. So if you try to make that, people will object because you know that your sample is biased one and there is no way you can assess the error into it. Right.
Okay. Okay, sir. Sir, and the next question is, if population size is very large, what should be the sample size? Because as a thumb rule, we generally take 30% of the population as the size of our sample, but that also makes the sample size very large.
Okay.
So how to cope up with that?
Okay. The one thing one need to understand is sample size is not dependent on population size.
Okay.
This is very, sometimes I find it, if I tell you a simple joke or anything, suppose if I say, suppose you come to me and then ask, I want to find out my blood group. And if I ask you, okay, I want to take out 30% of your blood, so will you be ready to give you 30% of your blood? This is also sample. No? You are taking a sample and then you are inferring about the entire blood in your body. So who says how you justify knowing, but as far as the blood group is concerned, I will give you only one drop. I will not give you 30% of my sample, but when I want to apply these to understand the some other thing, I need 30%. So there is nothing is there that 30% is the of your population should be your sample size. I don't know, this is very wrong, but I heard when I was in the college, they say that 5% of your population size should be your
Yes,
sample
sir. It
size.
is there still now.
It is there, yeah.
Yes, sir.
Even I heard one of my teacher, not in ICAR system, but when I was doing my undergraduate, the person who is supposed to be a expert in sampling, he mentioned this. I was also thinking, yes, 5% should be the ideal one. This 5% is a kind of thumb rule which is used when you do not have any other information about the population.
Right.
Right. But the sample size, why we require 1 drop is the characteristic you are measuring is highly homogeneous. So if you are taking 30% and if you try to find out what is the blood group or a single drop, it is going to remain same. So once we understand that there is no variability, you will not be requiring high sample size. The sample size estimation is a little bit tricky one. I will be trying to cover certain aspect, but still don't go in this that it is dependent on the population size. It is not.
So the main problem that we face is that how to determine the size of the sample.
Yeah.
I hope that you will be covering that in your next lecture. Yeah. Okay, sir. So we will have the next session at 3 p.m.
Okay. Okay. Thank you.
Thank you so much, sir.
Okay. So at 3 o'clock, right?
3 o'clock, sir.
Yeah, I have the next meeting link, so I'll using it and join.
Yeah, sure. Fine. Thank you so much.
Thank you. Thank you. Thank you, Dr. Pandit. Thank you.
इसको कर लेना भाई, कोई चीज होती है। ये किसकी है?